Very excited to kick off our afternoon session now with our Smart Mobility Keynote. And I would like to ask Dwight Smith, Founder and Chief Visionary Officer of Paragon VTOL Aerospace, onto the stage so that we can get going.
I wanted to talk today about a topic that is near and dear to me. And so I wanted to address about smart mobility and its future. So to begin, I'd like to say thank you for having me and for the opportunity. So there are a lot of exciting things happening in the transportation sector within this decade regarding electric vehicles, also known as EVs and VTOLs, which most people are familiar with as flying cars. So if you grew up watching cartoons as a kid, and for some of us as adults, the Jetsons probably resonate in terms of the flying cars or VTOLs we were promised would be a reality for decades, but it never came to fruition. By 2025, the global demand is trending towards energy-efficient initiatives in the transportation sector to reduce our carbon footprint and cut emissions by as much as 50%. To keep up with the demand for green technology in this sector, which includes electric vehicles, electric vertical takeoff and landing aircraft, also known as eVTOLs, autonomous infrastructure, and related supportive systems, the current supply chain just does not meet the demand. For example, the largest copper mine in the world, arguably, is in Chile, South America, and it handles over 20% of the world's copper production. An essential component for the electric grid, and is also something that we use in other areas of transmitting current. Copper is used for power distribution, energy, and energy transmission, and without it, the conductivity rate is not as effective. In order to ramp up to logarithmically and adjust to the goals set by the world's leading economies to cut carbon and emissions by as much as half by 2030, we would need to have about 5 more of these mines, like in Chile, operating within 3 years. So basically, we'd have to start over or find them, build them, and get them to the point where they can be commercially viable in 3 years to keep up with the current trends. To say that seems like an uphill battle would be an understatement. We would need bold, innovative, collaborative, and be assertive if we are going to make this a reality. I'm not saying that this is impossible. However, what I'm saying is that it will take a determined approach and a comprehensive solution for the 5 key areas that I will address for mutual success. And that would be in the areas of infrastructure, technology, sustainability, policy, and climate impact. However, at times, I may lean more to the VTOL industry, which I am a part of. But I believe the message will apply to the transportation sector overall. Please allow me to provide you with a little background on myself and why I feel so convicted by this moment in history. I was born in the island of Jamaica to a military father and a mother who was an educator. When I was 6 years of age, I used to graft plants together to produce different fruits from the same tree or vine. By the time I was 7 years old, I built my first glider aircraft and successfully flew it through our property and the neighbors with no formal training. The bumps and bruises during landing for my best friend, who was the pilot, did not earn me any favors, but at least we got the job done. I built the craft with absolutely no formal training, but only my imagination and common sense. I had a dream that one day, if I continued to develop my aviation dream, that I would eventually end up seeing the world. When I was in high school, I flew airplanes as a part of my aviation fundamental class. I graduated high school with a 1.789, I gotta get the 8.9 in there, GPA. You gotta earn everything you get. And at the bottom of my class, because I had a hard time focusing, and I felt that the school system was way too slow. A couple years later, I enrolled in a small college on an academic probation where, while completing the entrance exams and further testing, I learned that I was dyslexic. I immediately began to change how I learned and channeled my energy differently. I began to multitask with precision that on an academic merit as a 4.0 student, I transferred it to Purdue University a year later and majored in chemistry pre-med before eventually switching to marine biology to further my love for this planet. I then went on to create the patented diversion chemical known as perforation balls and related diversion sand for the oil and gas industry that's currently in use today. Our diversion products are biodegradable and enhance the recovery rate in order to improve efficiency. I use my income to create transportation-related inventions and solutions for the ambulatory services in the automotive sector. However, like my childhood love of aviation and a concern that transportation has not evolved as much as it should, then I began to explore ways to improve drone technology. The compelling moment for me was when my daughter was in school participating in her track meet, and I was stuck in traffic trying to make it but missed half of her races. The feeling that I had while sitting in congested traffic, that was the last straw. I am now the founder, main inventor, and chief visionary officer of Paragon VTOL Holdings and its subsidiaries, which includes Paragon VTOL Aerospace. I say all this because I want you to understand that I live the American dream and I have been involved with the transportation industry directly and indirectly my entire life, from behind the scenes to now on the forefront. The challenges we will face are exciting, aspirational, scary, and will be sometimes difficult. For the industry to grow at the rate of the demand, we need to take an outside-in approach and be bold, use new and fresh perspectives, collaborate when appropriate, and focus on sustainability in every aspect. I would first like to address infrastructure and some of the concerns and opportunities that exist. We need to start with our electric grid. The current grid in most cities is already reaching a critical mass. I do not believe in the past century the system in use today was developed to maintain an infinite demand on its resources. Microgrids like the ones that Paragon, in collaboration with established companies, are working together to build smart systems that can power homes, commercial buildings, neighborhoods, cities, and even countries, while providing green and renewable energy to cut carbon and emissions significantly. Our planet is filled with resources to currently make this possible. We need to be intentional and mindful of the technology being developed that will require tactical and sustainable power grids. According to a recent article in the Pew Research, EVs accounted for 2% of new car sales in 2020. However, a recent report made on June 1st, 2021 by UBS forecast that by 2025, 20% of all new cars sold globally will be electric. The report goes on to say that sales of EVs will increase 40% by 2030, and by 2040, virtually every new car sold will be electric. Infrastructure requirements of EV charging stations are constantly expanding, but not at the levels needed to support a universal charging network consistent with the current gas station grid and increased sales of EVs. Tesla has an enormous electrical charging network, but by and large, it was created for only Teslas in mind. Meanwhile, major cities and rural environments require a lot more charging stations to support the demand for electric vehicles. This also means that our current electrical grid will be once again asked to increase its capacity output to service this growing trend. Meanwhile, Our current infrastructure has been asked time and time again to increase its capacity to support consumption and demand. However, not all infrastructure in our cities can accommodate more vehicles on the road. While electric charging stations and raw materials required to facilitate this increase in demand, traffic seems to be increasing every day, with over 1 million new car sales in the United States on a monthly average. It is my humble opinion that a healthy conversation needs to be had between the oil and gas industry, the EV sector, environmentalists, and anyone that needs to understand how important all parties working together can solve the biggest challenges yet facing mankind in reducing our carbon footprint, slow down or reverse climate change, whether it's naturally occurring or man-made. I also believe there is a lot of misinformation on the role the oil and gas industry can play on our planet. For example, in order to make the plastic frame or rubber hoses for the charging connectors, you need resources from the oil and gas industry. In order to make most of the parts on your EV, you need resources from the oil and gas industry. Whether it is for plastics, fuel, or even glass, the oil and gas industry can be vital to helping the transportation sector in its goal to reduce the carbon footprint and cut emissions. Electric charging stations must be increased significantly to support major OEMs' shift to EV offerings. Companies like Toyota have created an incredible hydrogen fuel vehicle called the Mirai, with a range exceeding 425 miles on a single charge. I believe this presents an important opportunity for hydrogen vehicles. However, the cost of hydrogen must come down from its current state by developing better ways to produce and transport it efficiently. There are many types of hydrogen from different colors of the spectrum, some from the oil and gas sector, such as gray or blue hydrogen produced from fracking. There is also green hydrogen produced from steaming algae or plants, or even through electrolysis using sunlight and water. The point I'm making is there are alternative ways to produce hydrogen, and we need to work together to produce it more efficiently and expand the infrastructure to support hydrogen vehicles produced by other OEMs to follow suit. However, hydrogen systems need to be aggressively expanded in areas outside of regional pockets to create a better value proposition for cost-effective purposes. Our current infrastructure grid in major cities may have dedicated HOV carpooling lanes, but in order to achieve true level 5 commercialization of autonomous vehicles, we would need dedicated lanes for terrestrial autonomous operation. Level 5 is the quote-unquote holy grail for autonomous operation, meaning the vehicle is truly operating independently like an android robot to transport passengers, but current technological obstacles, unpredictable interferences, and current infrastructure has prevented some barriers to achieving level 5 autonomous capabilities in the time frame that we desire. Some of the most obvious challenges we face is that our current infrastructure is crumbling. Our bridges need repair. Potholes are destroying vehicles due to the crumbling roads. The list goes on and on. We need to either invest heavily in what is estimated to be a very expensive but necessary transportation grid, or we need to seek alternative transportation options. During the pandemic, the shut-in period when we spent extended periods of time often felt like a complete disconnection from the world and an inability or a scary time to get the basics that we needed, such as meals, mail, and medicine. Drone delivery services need to become an integrated part of our everyday lifestyle. It decreases the need to have more cars on the road. It provides a contactless delivery service, and the support system to operate them will create a surplus of new and sustainable jobs for the next wave of delivery services. Using this smart technology will not only improve efficiency, but can provide essential services in real time. Not since the Wright brothers and Henry Ford's Model T have we developed transportation grids to support the technology. Former President Dwight Eisenhower was instrumental in pushing an interstate and national highway program to advance mobility. When Tesla began its journey, the company focused on developing electrical vehicle charging stations along the coastal corridors while working with both state and federal governments to create incentives to its technology. Today, because of their bold initiatives, smart technologies such as EVs are now more important than ever and critical to us pursuing cleaner air quality in dense environments and reduced noise pollution wherever they are utilized. Our rail system, once thought to be a technological marvel, without government assistance would be in a difficult operational position had it not been for federal subsidies. I believe in addition to supporting improvements on our current infrastructure, that we need to look to the skies for the next level of transportation that doesn't drain taxpayers' continued monetary contribution to maintain expensive or failing business models. VTOLs are the next smart technology of transportation and a solution for the next century. Now, obviously, I'm somewhat biased because of my company's position with our current efforts to build the VTOL sector, but it's also because I have a strong conviction that the technology is a lot closer than most people realize. In order for VTOLs to become a sustainable reality, there needs to be a reliable and open platform of vertiports, reliable air traffic management systems, pilots, maintenance, repair facilities, etc. The vertical airports, or vertiports I'll call them, will need to enable not only a single VTOL company, but all VTOL companies to share their infrastructure for advanced aerial mobility, along with provide all necessary resources to secure and enhance the overall safety and experience. In every aspect of planning and implementation, regulatory agencies need to be contacted and in lockstep with these bold initiatives. There will need to be an established ecosystem for VTOLs to become the mainstream choice. For investors to get a positive return on their development through commercialization without an IPO event, there will need to be more than 500 to 1,000 VTOLs in operation to support the alleged thousands of proposed vertiports for it to be a sound business model. Which leads me to my next point, which is that of technology. I believe technology is about to explode in terms of disruption within transportation. Recently, Ford Motor Company unveiled its Ford F-150 electric truck, which pushed boundaries beyond what most people with whom have been accustomed to Ford ever thought was possible. Its smart technology and power system can provide sustainable energy to power a home for days while maintaining the strength of an F-150. General Motors sold out their new electric Hummer, and so many others are debuting their products and are entering the market branding their technology, such as Lucid Motors. We need to embrace the technology as it integrates into a crowded field of internal combustible engines. The time for being combative needs to stop and replace with collaboration. There is so much more that we can achieve together than separately. Most recently, Joby Aviation not only took to the skies, but also debuted on the stock market as a multi-billion-dollar eVTOL company. Although the stock had a few bumpy moments, I could not be happier for them and the amazing company that they've created. In fact, I believe in time, their valuation will be north of $30 billion because of the amazing work and technology that they are introducing into our system. We need more companies like Joby, Archer, Lilium, EHang, Volocopter, Beta Technologies, and others to exit while providing us with a view of what this decade will look like for mankind and for transportation. I believe there will be a roller coaster ride both technologically and on the stock market, but I'm also very bullish given what my company Paragon has done, that these companies will be amazing chapters in history on how they improved our infrastructure by providing technology which enables mankind to reduce congestion on our roads and get our time back. A recent report by Morgan Stanley predicts that the global eVTOL market by 2050 in its base case scenario will be worth an estimated $9 trillion of the projected GDP, and in its bullish case, over $18.9 trillion, which represents roughly 11 to 12% of the global GDP. Comparatively, the automobile sector today represents around 3% of the GDP. We need to create or further develop the autonomous infrastructure grid with technology. 3D spacing will be valuable and should be integrated with the existing GPS technology. VTOLs should have traffic management software that interacts with terrestrial transportation as well as other aircraft. Shared data will be critical to pushing forward the VTOL industry while providing metrics by which to govern for the FAA. According to the International Federation of Air Traffic Controllers, there is a global shortage of air traffic controllers by 10%, with another 15% needed to transition to next gen. We will need a smart technology system to attract new and sustainable source of recruits. We need a robust system that attracts more air traffic controllers, autonomous ground traffic controllers, and pilots to catch up with the shortage of related positions. Aviation consultant Oliver Wyman predicts that by 2023, just a couple years from now, there will be a shortage of airline pilots for commercial airlines exceeding 12,000 vacancies. The transportation sector needs to address this shortage with manpower and technology, or the hardware themselves will be nothing more than shiny objects. Disruptive technology should be shared for the advancement of the transportation industry. Massive amounts of data need to be collected to provide consumer and oversight confidence. In the words of Frederick Douglass, without struggle, there is no progress. I believe failure is essential to understanding how to succeed with confidence. If companies choose not to share information, then emerging technology will slow to introduction and public/government agency acceptance. We need to move forward together boldly and with conviction. We also need to have improved battery systems to support the transportation sector, especially in the VTOL applications. There are many concerns with battery usage in VTOLs. Density is an issue with the current battery. Weight and how it affects payload needs to be improved. Cost is too expensive, along with life cycle, to become an effective value proposition. Thermal is almost certain as a requirement. And lastly, the supply chain must improve significantly, especially when VTOLs will be competing with the EV sector in the supply chain for battery resources. Another technological problem and opportunity are payload and supportive equipment. Paragon, for example, has patented technology which enables the exoskeleton of an aircraft or other transportation platforms to deflect icing and freeze-related concerns. This technology eliminates the need for de-icing equipment on planes or VTOLs or frozen door handles on EVs. It will also reduce payload constraints because less equipment is needed and will enable cargo and passenger payload to increase. In addition, our technology can be used for heating surfaces within the engine interior, seating, or even our commercial grid for roads, highways, byways, rooftops, sidewalks, you name it. Payload is always an important factor in aviation. And in developing this technology, it is weighed in ounces and not in pounds. Technological advancements need to be made in the areas of composite fiber, to which Paragon and other companies are creating new and bold substrates to tackle not only the reliability, but also the cost factors associated. It seems that a lot of companies from the EV sector, airlines, and now the VTOL companies are pushing to use carbon fiber, which will further stress the supply chain. The key to this improvement will be sustainable resources. Our demand for cobalt for the battery sector has not come without a set of challenges. In the Congo region of Africa, which accounts for the bulk of cobalt mining for global supply chain, there have been multiple lawsuits related to human rights tragedies regarding children as young as 6 years old being used to work in these mines or have lost their lives while working in these mines. Imagine your 6-year-old child in the hot sun working in a mine to feed the world's hunger for cobalt, to power cell phones, laptops, and yes, EV transportation vehicles. I say all this to say the increased demand for green technology in the transportation sector has been often overwhelming on the system. Lithium mining has been taxing on the supply chain. The transportation of raw materials is not environmentally friendly, nor is the disposal of battery systems. However, it presents an enormous opportunity for entrepreneurial approaches to facilitate solutions. Policy initiatives are extremely important for autonomous operations of cars and VTOLs. The FAA has been working tirelessly in trying to understand and develop criteria to provide guidance to the VTOL sector for advanced aerial mobility. AFWERX has been creating pathways to certification for VTOL companies while understanding how to develop a safe and scalable environment for VTOLs to peacefully coexist in our current transportation sector. It is this type of collaboration that is essential for forward progress and provides a glimpse into how our federal government is taking this initiative seriously to shape policy and provide practical solutions. Congress has been putting together support initiatives for VTOL commercialization, which is very encouraging. The Texas Department of Transportation is aggressively exploring all options to improve existing technology while looking to the future for the integration of new technology to build the transportation for the next century. Policy will guide the ship for the emerging VTOL industry, just like it did for the automotive sector. We must also be sensitive to our role and involvement with how we improve technology and its impact on our climate. There are climate policy initiatives to help governments, businesses, and financial institutions, but they're also designed to drive economic growth while addressing climate change. Whether climate change is a naturally occurring event or man-made, we must recognize that these weather patterns are real. We must also recognize that carbon and reduction and cutting emissions is equally important. We don't need to eat the elephant whole, but we can take steps at a time to improve efficiency without being selfish. As I previously stated, I am a first-generation oil man, but I am also a steward of this planet. I believe we can walk and chew gum at the same time. My Purdue football coach, Bobby Turner, used to say, "The rule about common sense is that common sense overrides the rule." I hold that quote near and dear to my actions in terms of how I go about building one of the most disruptive companies in our modern time. The importance for us to embrace the youth of today to tackle these main points is why I am fully committed to STEM learning for all middle school and high school students as a precursor to employment post-high school or before entering the collegiate environment. So in parting, I would like to thank you for the opportunity to speak with you today and look forward to seeing you all along this amazing journey.